All right. Do you think physics will ever have a complete theory that explains everything? And will there always be unanswered questions? Well, the answer to that question is largely dependent on what you mean by everything. When we have used the phrase theory of everything as string theorists, which I don't favor that language at all. It's kind of antagonistic to people in science working on another field. If you're working on the theory of everything and they're not, what are they working on? Theories of nothing. And I don't mean nothing in the profound sense of what do we mean by nothing. I just mean something that nobody cares about. So that's why I don't like the language. But when we have used that language, it was really a very limited version of everything, referring to the fundamental particulate ingredients, or in quantum mechanical language, whatever you want to describe them, and the fundamental forces by which those ingredients influence each other. So it's a very reductionist stance, the thought being that if you know the ingredients and you know their behavior, then at least in an in-principle sense, you understand everything, because everything is made of those ingredients acting on each other through those forces. But the in principle needs to be underscored. Nobody ever imagined that a theory like string theory, or whatever your favorite unified theory of everything might be, would, be able to predict our behavior, tell us what we're going to have for lunch tomorrow, or be able to understand the nature of consciousness or the nature of life. I mean, perhaps a way of saying it is this. One way to organize your thinking, and this is a good exercise, but one way to organize your thinking about the universe is to say, look, there are big things, stars, galaxies, black holes, and so forth. There are small things, molecules, atoms, and subatomic particles. But there are also complex things where you're not talking about a single black hole or a single electron, the way we do in a course on astrophysics or a basic course on quantum mechanics. You're talking about a huge number of, say, particles that are swarming around together in some hot bath, a liquid, like in a human body. And that's a completely different arena from the big and the small. The complex is different. Now, it doesn't mean that there are fundamentally new laws, but the language that's useful for talking about the complex is generally not the same language as the big and the small. You need to talk at the level of aggregates, right? You don't want to talk about individual electrons when you're talking about a human cell. You want to talk about the chemical nature, the biological nature, and that takes you to very large molecules and to cellular systems, and then collections of cells, and then collections of cells that yield some multicellular living system. And even beyond that, when you get to complex life, who's ever going to use an electron to talk about the mind? It's just incongruous. It's not the relevant language for deep insight. There are certain ideas that you can extract by blending these things together. And if anybody asks about it, free will, I think, is one of those. But more generally, theory of everything would be very limited in its applicability.